All right, 3.2, solving systems by substitution. So I mentioned in 3.1 that there are three different ways that we can solve systems. We looked at graphing in 3.1. So 3.2, we're going to look at what we call substitution method. So it's going to be kind of some things that we've done before, plugging equations into equations, but simplifying afterwards and work through that. So we're just going to work through a few problems here and make sure we have that down so that we can solve this way as well. And everything has its own benefits, so there are those cases, okay? So let's just hop right into the examples here. We don't have any definitions for these. So we are solving. So number one here, we have y equals 5 minus 4x is our first one. 2x minus 3y equals 13. Okay. Now, when we solve doing substitution, we think back if we had just x equals a number or y equals a number, we subbed in, we took that and plugged it into that variable and then worked it out. And that's exactly what we're going to do here. So as long as we have a variable by itself, meaning x equals or y equals, one of the two, then we can use substitution. So in problem number one here, we have that. We have y equals something. So what it equals, we're going to take what that is. So it's 5x minus 4, and we're going to plug in for y right here. Okay, so we want to do that and work that piece out. So I'm going to do that below here. So now we're going to have 2x minus 3 times, and instead of y, we're going to have 5 minus 4x. Equals 13. It's very important to put those parentheses because we got to distribute before we can combine like terms. And now hopefully you see the reason why we're doing this is when I look at my new equation here, I have nothing but x's. There are no y's anymore. So that allows me to solve for x. All right, so let's distribute this negative 3. We're going to get 2x minus 15 plus 12x equals 13. Okay. All right, so we can put those things together. So 2x and 12x is 14x minus 15 equals 13. So all I did there was combine those. Let's add this 15 over. So 14x equals 28 when I move that 15 over with the 13. And now we divide by the 14, so x equals 2. Okay? So now we have our x value. Now we need to find our y value. So we're going to take that x value, we're going to plug it back into either one of our original equations. But I like to make my life easier. I'm going to take it and plug it in right there because I already have y by itself. So once I plug it in, it's simply type it in my calculator essentially for that. And so that tells me y equals 5 minus 4 times 2. I'm taking that 2, plugging it in for the x. All right, so y equals, I don't know what was happening there. Okay, so y equals 5 minus 8. So y equals negative 3. Okay, so now we have x and y. So that's my solution. Is 2, negative 3. We can always check it if we wanted to, plug it back into both equations and make sure it works. And you'll see here that it does. Okay. We could even go as far as the answer. Is it consistent or inconsistent? Well, we found a solution, so it's consistent. Is it independent or dependent? Because it is one solution, it is going to be independent. They are two different lines. Okay. But I don't believe you're going to have to do that in this section. But we could if we needed to. All right, number 2. 2y plus x equals 9. And x equals 3y minus 3. All right, so we look to see, do we have a letter by itself? We do here, we have x. And it doesn't matter which letter is by itself. It can be x, it can be y. Don't move things around to get a certain one. Use what they give you, okay? X is by itself here, so I'm going to take it and plug it in for X. 2y plus 3y minus 3 equals 9. All right, well, we can actually ignore those parentheses. You know that I like to put those in so that you see what I plugged in where. But since there's nothing in front of it except for a plus sign, I'm just going to go ahead and combine like terms. 2 plus 3 is 5y minus 3 equals 9. I'm going to add the 3, so we get 5y equals 12. Divide by the 5, so y equals 12 over 5. And we do like to leave those as fractions. Don't change them to decimals unless they specifically say to round, which I doubt they will do, and leave them as an improper fraction, not a mixed number. Okay, so there's our first one. Again, I'm going to take and plug that back in here because it's already got the variable by itself that we need. And so x equals 3 times 12 over 5 minus 3. Okay, so now we need to get common denominators and all that stuff as we move through these. So x equals, this is 3 over 1, so we get what, 36 over 5. This 3 times 12 is 36. I know that this is a whole number, so I'm going to need to change that over to 5s. So it's going to give me 15 over 5. Okay, I'm multiplying times 5 there on those so that I can get a common denominator because I'm subtracting fractions on the next piece. Well, 36 minus 15 is what, 21 over 5. So we have our x and y. We always write it in x first. So 21 over 5, comma, 12 over 5 is our solution. Okay, so we can get fractions. It's not a big problem there. And that's one thing that substitution and also the method we'll learn in the next section do for us is in graphing, it's hard to see if we get fractions. We really want whole numbers. But in these methods, we can see those ugly fractions and be able to still get the correct answer. All right, let's look at a couple more here. Right, number 3. 3x minus 4y equals 14. And then 5x plus y equals 8. All right, so here you can see nothing is by itself, but we can get it there. Okay, and so let's do that. So we know that for the second one here, so I'm looking at this one, that I can get y by itself really easily. Now you can do any letter you want, but make your life easy on itself. Don't pick getting this y by itself because I've got to divide by 4 and it's going to create a fraction. Same thing with the 3 and the 5. If I do those things, it's just going to get ugly, okay? All right, so let's subtract this over. So that's going to give me here that y equals 8 minus 5x, or negative 5x plus 8, however you want to write that. Okay, and so that's what we're doing there. We're just simply transitioning that equation. So now I'm going to take this 8 minus 5x, and I'm going to plug it into y there for those. Now we've got to go to the other equation. Remember, these two are the same thing, so I can't plug it back in here. I have to go back up to my other equation. All right, so 3x minus 4 times 8 minus 5x equals 14. So now we got to start distributing. So 3x minus 32 plus 20x equals 14. So we put those together, we're going to get 23x minus 32 equals 14. I'm going to add the 32 to the 14, so 23x. Said it right, I wrote it wrong. 23x equals, add that 32 over, and we're going to get 46. So when I divide, x equals 2. Now we can take and plug this in, and we can even use this modified version. So we're going to plug that back in here so that we can get our y value. So y equals 8 minus 5 times 2. So y equals 8 minus 10, or y equals -2. So we get 2, -2 for our solution. Okay. All right, number 4. 2x minus 3 equals y, and y minus 2x equals 1. Well, even though it looks a little weird, y is by itself, so that's good. So all of this can go into y. So that tells me we have 2x minus 3 and this y, so minus 2x equals 1. Well, again, the parentheses here really don't matter. I always like to put things in parentheses when I plug it in. So I can combine, we see that 2x minus 2x kill each other. So that tells me -3 equals 1. Well, -3 doesn't equal 1. There's no x to solve for. This is not true. So this is no solution. Okay, since that's not true. So we do look for those things. We can still have a no solution with these pieces. All right. Let's see, number 5. Y equals 4 minus 3x, and then 12 minus 3y equals 9x. Well, it looks like y is already by itself there, so we can plug that in. So that gives me 12 minus 3 times 4 minus 3x equals 9x. All right, so we distribute there. We get 12 minus 12 plus 9x equals 9x. Well, 12 minus 12 is 0. They kill each other. Okay, so 9x does equal 9x. We need to subtract those x's over. So when I subtract it over, I get 0 equals 0. Well, that's true, but I don't have an x to solve for to plug back in. So since this is true, this means infinitely many solutions. Okay, infinitely many solutions there for that. So when you get it down, it's a number equals a number. If it's true, it's infinitely many solutions. If it's false, it's no solution. So we look for those just the same. Okay, so this is how we're going to use substitution. Take those things, we plug them in, and we work through them. All right.